Hello everyone and welcome to this CDK Day talk about schema-driven OpenAPI development with AWS CDK. First things first, my name is Palo. I'm a lead technologist at Alma Media where I've been about 11 years. Before that I did some freelancing. Nowadays my favorite languages are TypeScript and Go, although I constantly find myself making up excuses to learn Rust someday, but we'll see how that goes. I've been using AWS since 2014 or so, and since 2016 I've been pretty much focusing on serverless. Also, I'm an AWS community builder focusing on developer tooling. There's also some links and social media handles, so definitely feel free to connect with me after this presentation. Briefly, some context for this presentation about Alma Media, which is a digital services and media company operating in 10 European countries with 50 plus brands, 1,500 employees. We started our AWS journey around 2012, and in 2016 we started working with serverless tools such as AWS Lambda. And on late 2018 we jumped into the CDK bandwagon, and today we have about 170 AWS accounts. And we build a lot of APIs, both GraphQL and RESTful APIs, and more often than not we do it with AWS CDK. Usually the API infrastructure looks something like this. We have some CloudFront distributions, and behind those there are API gateways for RESTful APIs and AppSync for GraphQL APIs. Those then integrate to various AWS services. Often there is the Lambda function backing the integration, but more often than not nowadays we are using this so-called functionless setup where we are directly integrating to various AWS services such as DynamoDB, EventBridge or Step Functions Express workflows. When you're developing RESTful APIs with CDK, it looks something like this. First you initialize this REST API construct, then you add some resources into it, and after that you define some methods and their integrations. And it's really nice way to do API gateway setups with CDK. But what about API documentation? Well, for RESTful APIs nowadays the kind of a de facto solution is to use OpenAPI. Some of you may know it as Swagger, but since version 3 this is called OpenAPI specification. Essentially, it is a way to describe your API in YAML syntax or JSON if you prefer, but it's just a way to describe what kind of endpoints, methods, and request parameters and response models your API has. And let's say if you have some kind of authentication, then you can describe how that authentication works, etc. The nice thing about OpenAPI is that there is a lot of tooling built around it. For example, you can generate API documentation out of your OpenAPI schema. There are many popular open source tools to do that. Couple examples are Rapidoc and Redoc, which both are really nice. They generate these really nice looking documentation websites that essentially showcase how your API works with different parameters, etc. And people can even try out your API directly from these documentation websites. Also, it's not just about these documentation websites. You can use OpenAPI for many other things. For TypeScript, there's this really nice tool called OpenAPI TypeScript, which just reads your OpenAPI schema and then generates TypeScript types out of it. It's really useful when you're developing, let's say, Lambda functions that are behind an API gateway. So you don't have to redefine the Lambda function handler events. Instead, you can use these generated interfaces directly. So they match exactly to the data that API gateway is passing into your Lambda function event. There are other tooling for other programming languages as well that achieve this similar functionality. But you can also use that same tool for client-side development. It doesn't have to be just your API backend itself. Let's say you're developing a mobile application with React Native or some website frontend. You can use the OpenAPI TypeScript again to generate the typings for the API and then use those typings in the frontend development. In the right hand side, there is a screenshot from this tool called MSW, which can actually intercept requests on a network level on your browser. So it effectively mocks the API responses and requests and responses for the website frontend. So when you pair MSW with this OpenAPI TypeScript that generates the TypeScript interfaces for your API, it really enables frontend developers to actually develop against your API specification, even if your API has not yet been built and deployed. So in a way, your front-end developers can work asynchronously as they can build the website frontend or the mobile application by using the types generated out of the OpenAPI schema, even if the API itself is not yet ready or implemented or deployed to API gateway. It's just enough that they have the schema available from which they can generate the TypeScript types, and then they can mock the actual data while they're developing. That is really powerful. So what about OpenAPI with CDK? Well, if you're developing with the REST API construct, you can add response models and other metadata to your API definition, not all, but some. And once you've deployed, you can go to stage settings in the web console UI and export OpenAPI definitions from there. But that is a bit of a challenging because it requires that you have to first develop the API, deploy it, and once you've deployed it, then you can export the schema. And as the schema is really useful in the API design phase, as you can also generate that documentation website, which you could give to stakeholders and involve them into the design process of the API. For example, you could have either internal or external stakeholders that are, for example, integrating to your API, so you could involve them. So it's really powerful to have the schema and the documentation available even before your API has been deployed. Also, if you have people either in your organization or outside your organization that are building API clients, it's actually useful that they can start the the client development even before the API itself is actually fully ready. So this is kind of annoying that you have to wait for your API to be fully ready and deployed. So instead of using the generated schema by API gateway, I kind of recommend to actually treat the OpenAPI schema as the single source of truth, that you define it yourself and use that to generate the API gateway instance. So the OpenAPI acts as a single source of truth. So you generate the API gateway from it, but also you can then use the schema as part of the design process. You can generate the documentation that you can give to stakeholders and people who are creating clients and integrating to your API. That's really, really powerful. So in CDK, you need to use spec REST API construct to achieve this. Essentially, you instantiate spec REST API construct, and as a prop, you give it an API definition which just points to a file containing your OpenAPI definition. The problem with this approach is, and I'm quoting the documentation here, all resources and methods need to be defined as part of the OpenAPI specification file and cannot be added via the CDK. Essentially, this means that we end up with a lot of hard-coded values. So we need to have these X-Amazon API Gateway integration objects and other X-Amazon extensions in the OpenAPI definition file. And this is really problematic for things like ARNs and other dynamic values that are defined by the CDK code. In this example, we have the Lambda function invoke URI for the API gateway. So we definitely don't want to hardcode these kind of values in our OpenAPI definition. People have tried to solve this by using some kind of a templating or string replacement solutions, that they have some placeholder value which they then process in the CDK code before assigning the processed schema definition to the spec REST API construct, and this definitely works. But it's still quite annoying that we have these X-Amazon API Gateway extensions in our OpenAPI specification. I don't like that. That sort of it exposes implementation detail, especially if you're sharing these OpenAPI definitions to external stakeholders. So you don't necessarily want to provide them information of how your API gateway is configured. and even if you are using API gateway. Then it's just not about the Lambda functions. When you're doing direct AWS service integrations like DynamoDB, you need to pass a lot of different values into the template or into the OpenAPI specification. You need to have the ARN of the, in this example, DynamoDB database, the action name, the table name, the key name, etc., etc. So there's a lot of things you need to pass from CDK to your OpenAPI definition. And here's an example of cognito user pool authorizer. You need the authorizer type, the user pool ARN. Or if you're even doing something like configuring the API gateway request validators, that also involves adding quite a lot of this Amazon API gateway extension syntax, and that's kind of annoying to have in the OpenAPI definition file. So to summarize the challenges with API gateway spec REST API construct, we need to build our own solution to pass data, effectively CDK tokens, from CDK code to OpenAPI definition, so that the tokens are then resolved during deployment time. Then we need to have a lot of these ugly Amazon API gateway extensions in our OpenAPI definition, and that often leads to duplication, that you're just copy-pasting those extension fields all over the place in your OpenAPI definition. So this is why OpenAPI with CDK can be hard. So let's try if we can simplify that with a high-level construct, because CDK is all about constructs and you can create your own. So what I'd really like to see is something like this, that we have the OpenAPI definition, which is kind of a clean and simple and doesn't contain any hard-coded values, of course, but it doesn't even contain any Amazon API gateway extensions. So it's just, the pure default OpenAPI tree definition. But then for API gateway integrations, I want to use CDK and write those integrations in type-safe CDK code. So I would like to get the best of both worlds. So how could we achieve that? So we could create this CDK construct that manages these interactions or integrations and then somehow consumes this OpenAPI schema and then merges them together. So you'll have the OpenAPI schema in a separate YAML file, but then you have the integration definitions in CDK code, and those get merged together, and they will then generate the API gateway REST API. So how we would approach this? Let's first take a look what we all have already. So we have the API gateway spec REST API construct that is responsible on generating the API gateway for us based on the API definition in OpenAPI schema, which is then resolved by this API definition class, which actually implements the exposing the OpenAPI definition to spec REST API construct through either as an inline definition or an S3 uploaded asset. So let's utilize these, but we probably want to extend these as we want to sort of define our own implementation on top of these. Then we also have these different integrations such as the Lambda integration, HTTP integration, AWS integration, which is really useful. Then we have also the mock integration. So we definitely want to utilize these. But in OpenAPI, we need to use these API gateway extensions, Amazon API gateway extensions. These have varying properties and they are definitely not the same as the CDK integrations. So we need to create the TypeScript versions of these various Amazon API gateway extensions. So we're creating interfaces for them. Then we need to map the values from the API gateway integration props to these new interfaces that we just created that match the API gateway OpenAPI extensions. And then we need to have some code that maps the different values from that previous type to that new type. I'm not super proud of this code snippet here, but it gets the job done with certain defaults that CDK uses as well. Once we've done that, we are able to define this our API construct that essentially takes this source OpenAPI schema as a property, and then you can add validators, you can add authorizers, and finally you can add those different paths with their different methods and different integrations to those methods. And this is a really nice way of defining an OpenAPI based or an API that is based on an OpenAPI schema definition, but you can then assign all the integrations and authorizers and validations, etc., to CDK code. And yes, I know this is kind of like drawing an owl. So there was a huge gap from the basic concept to the actual implementation of this API construct. But 20 minutes is not enough to go through every implementation detail of this construct. But just to sort of bring home the point about trying to use as much of the existing functionality in CDK, all those different integration props and others, and then do some mapping between those into Amazon API Gateway extensions that you can then merge with the original OpenAPI schema definition. For that, we've actually created this open source construct. It's called Alma CDK OpenAPIX, and it's actually based on our internal implementation. We've been using CDK for several years now, and we've also been building our own in-house CDK constructs for some time. And we are slowly open sourcing some of them, so all the people that are interested in them can use them. And we've had this OpenAPI construct for a year or two now, and this is a completely new construct, this CDK OpenAPIX, but it's based on the existing implementation, although everything internally has been rewritten, and also it's still quite new, so expect bugs and breaking changes and new features and things like that, as it's still fresh off the oven, so to speak. But if you want to try it out, you can already install it today by installing it from the Alma CDK scope on npm and then OpenAPIX. And currently it supports Lambda integrations, mock integrations, HTTP integrations, and AWS service integrations. And to be honest, the AWS service integrations were one of the biggest motivations for us to build this, because defining those, let's say, DynamoDB or EventBridge or other service integrations in the OpenAPI YAML format is really pain in the butt. So having, ability to do AWS service integrations in CDK for existing OpenAPI schema YAML is really powerful. Also, we're planning to add step function express workflow integrations at some point, but it's still as a GitHub issue. Nothing has been done yet towards that. Then it supports request validators, Cognito authorizers, and Lambda authorizers. Also, it helps a bit with cross-origin resource sharing configurations. And sometimes you want to remove some fields from your OpenAPI definition before it gets sent to API Gateway. For example, if you have a really long descriptions and examples and things like that, you might want to strip them out because it's just unnecessary data. Or sometimes you might want to inject some fields there. So this supports both injecting and rejecting values to that OpenAPI definition file before it gets sent to API Gateway. And finally, it supports both inline definition, where the processed OpenAPI definition is inline to the resulting CloudFormation template, or especially for large API definitions, you can set the upload property to true, which means that the OpenAPI definition will be uploaded to S3 by CDK during deployment, and then the resulting CloudFormation template will reference the S3 object. So feel free to try it out and report any bugs you'll find. And even if you're not directly using this, there might be some useful ideas how to integrate OpenAPI to CDK development. But if you build your own solutions, I really would love to hear from you, because there definitely isn't that much resources and blog posts and articles and Stack Overflow issues on this topic about CDK with OpenAPI and schema-driven development. So feel free to reach me on this subject. And generally speaking, the main point of this talk was to just expose some of the pain points when you're developing with CDK and you want to use that OpenAPI schema-driven development model. So I'm really hoping that in the future CDK community will sort of put some effort into this, and there will be other constructs and other tools around this area, and maybe on someday CDK core will have some more high level support for OpenAPI in some form. So let's see, and I'll leave you with that, and thank you very much for joining into this session.